everybody. My name is Giovanni Lucente. I'm a PhD student at the Institute of Transportation System of the German Aerospace Center. The topic of my PhD is is the decision making in the urban traffic environment. The paper that I've presented in the journal Automotive Innovation deals with a predictor that is, of course, necessary for the decision making in each traffic situation. The title of my article is a Bayesian approach with the prior mixed strategy Nash equilibrium for vehicle intention prediction. Basically, this trajectory predictor is it's based on a Bayesian approach. The Bayes theorem is, as you know, is composed by a prior and a likelihood that gives posterior. The prior, we have decided to use as a prior the modelization of a non-zero sum polymatrix game, and we compute the mixed strategy Nash equilibrium of this game, and this is the prior estimate. Then, as a likelihood, we have defined a distance measure that is based on Kullback-Leibler divergence. The environment is modeled so that each traffic participant intended as a car has a set of trajectories that can take in the future. These trajectories are the actions of the agent in this polymatrix game. So as a prior estimate, we compute the mixed strategy of this polymatrix game. The output, so, is a probability distribution for each trajectory of each car, so a probability distribution over the actions of the agents. This kind of the computation of a Nash equilibrium, mixed strategy Nash equilibrium for this kind of games is in a complexity class that with the polynomial time tractability. So this allows for online applications. Once the prior is computed, then the likelihood is also estimated. This likelihood is based, as I said, on a distance measure between the possible trajectories of each vehicle and a short-term trajectory that is based on the acceleration that we estimate, the acceleration and steering angle that we estimate from the vehicle. In this way, let's say that the likelihood corrects the prior estimate. The prior estimate is a rational prior that is based on a rational choice of the agent. This rational choice is then corrected by the likelihood, considering the fact that an agent can also behave in an irrational way. So that, for instance, if the rational outcome of the polymatrix game of the mixed strategy Nash equilibrium, the mixed strategy Nash equilibrium is to stop at the intersection, then we notice, the sensors notice that the car is not stopping, then the trajectories that do not stop at the intersection are weighted more and so are corrected, let's say. So, once the prior is computed and also the likelihood is computed, then the posterior is easy to compute based on the Bayes theorem. And this posterior, as I said, considers in the estimate of the posterior, there is the consideration over the rationality of the agent, so the rational choice of the agent, and let's say what we record from the data, what we see from the current traffic situation. So considering also the current trajectory that the vehicle is going to take, let's say. So basically, we have noticed that the approach shows good results in a simulation, in our simulation environment, that is ADOR, in the long-term horizon. And the computational complexity, as I said, allows for online applications. Of course, if you have some questions, I'm really happy to answer. You can find my email, and thanks for watching.